So we are going to start from where we stopped the other time. We have this issue of downward projection at an angle. A body is thrown downward. As you can see, the angle is theta, and it goes down from an height h. When it goes down, the value of y starts from up down to the ground. Then that's why we say y naught is 0. Then when it reaches the ground, then y becomes minus h, because this is a negative y-axis. This is plus, and this is minus. That's why we have, when it's on the ground, on this ground, then y is this. Then when it's on the ground also, the time, we just call it capital T. When it's on the ground, where it will fall at b, the distance x now become r. So these are the formula when the body is on the ground. You can calculate the range using this formula. You can calculate the time taken to reach the ground, use this formula, and also the velocity. But when it's not on the ground, you can use this one to be able to find the other thing you want to find. So I hope we are there. Okay, so are you following? Okay. So now let's see how we are going to proceed here by solving this example. Now you see there are two cases. There is a case when the angle is 0, that is horizontal. The body is like this, and when the angle is not 0, greater than 0. So we have two ways. So let's see that example. So now this is the example we want to solve. We want to solve this example from here. So let's see how do we solve it here. We say a gun is shot horizontally at this from the ground. So this is the height. The initial velocity of the bullet is this. How long does it take the bullet to hit the ground? So now we are going to solve this one. The position of the bullet after 0.5 seconds. Then again, we have the velocity of the bullet after half second. What is total? Then what is the total horizontal distance traveled? Calculate the velocity to which. So once you stay on the ground, so strike the ground, you know the formula is that to hit the ground, then t. So if we go back to our formula, when the body is on the ground, so now you can see when the body is on the ground. So this is the formula we're going to use, right? So this is the formula we're going to use for us to get the time taken for the body to reach the ground. So we are going to apply that one and try to find the time taken for the body to reach the ground. So now let's see how do we find those ones. So now let's see how do we find it. First of all, we start by defining our theta. Our theta is 0 degree. Why? Because it's horizontal, right? It's horizontal. That's why theta is 0 in this case. Then our y naught is always 0. Our x naught is 0. Then our value of g is 10 meter per second square. And then the initial velocity is 65.3 meter per second. And then the height from which it falls is now 13.52 meters, right? From the question. So now the first part we want to answer. The question says we have to find the time, right? So we now see that on the ground, what happens? T becomes TH, right? T becomes TH and Y becomes minus H. So there's a formula there I give you, which is minus H equals to minus U sine theta all multiplied by capital T minus half GT square. Now it is to put all the values. The value of H is this. So I'm going to have minus 1352 equals to minus U, which is 65.3. Sine of theta is 0 degree because it's horizontally, time t, which we are looking for, minus half, which is 0.5. G is 10. Then we have what? T square, right? So are you following? Then we have 13.52 is equals to what? Then what is sine 0? Sine 0 degree. So you see sine 0 is 0. So everything will become 0. 0 times t minus 0.5 times 10. That is 5. We have t square. Then 0 times t is 0. So we have minus 13.52 is equals to minus 5 t square. Why the noise? Why we are making the noise? So you see, please, the noise, please. Who is making that noise? So from here, so you see, sine theta is 0. That's why everything reduces down to t. So if we make t the sort of the formula, we now see that our t minus cancel minus is going to be square root of 13.52 divided by what? 5. Our answer is going to be 1.64 seconds. So that is the way we do this one. That is the time taken for the body to what? For the body to strike the ground. So that's out to date. The next question is to calculate what? The next question now is to calculate so the next question is to calculate what? Okay, now the next question is to calculate the position of the object after what? 0.5 seconds. So that means from here, our t here is 0.5 seconds. That means we want to find x, and then we want to find what? Y. So that is it. So the value of x is just u cos theta times t. Then u is what? U is 65.3. Cos of theta is 0 degree times t is what? 0.5. Cos 0 is 1. Then 65.3 times 0.5. If you do that, the answer will give you 32.65 meter. Then likewise, we find y. Similarly, y is going to be minus u sine theta t minus a half gt square. Now put everything. U is what? U is 65.3 sine of 0 degree times 0.5 minus half 0.5 times 10 times t, which is 0.5 square. Sine 0 is 0. So the whole of this becomes 0. The whole of this becomes 0. So we have minus. Then 0.5 times 10 times 0.5 square. So if you do all this one, you end up going to have 1.25 meters. So therefore, the value of x is 32.65 meters, while the value of y is minus. Minus means is going down, 1.25. So that's how we calculate what? The value of what? The value of the position at time 0.5 second. Also, question C looks similar. We have to find also the velocity, right? We have 0.5 second. What we want to find is the velocity. Before that, we need to find velocity along x. Velocity along x is always u cos theta, right? So which we see. Substitute the values there. You have u is 65.3 cos of 0 degree. Cos of 0 is 1. So here we have 65.3 meter per second. So that is how we calculate the velocity along x. Then also, let's calculate the velocity along y. The velocity along y is going to be similar. But this time around, we're going to have minus because sine is negative in the fourth quadrant. Then minus gt. So put all the values. Minus u is what? 65.3 sine 0 degree. G is 10. T is 0.5. If you sine 0 is 0 times this will become 0. 10 times 0.5. That will give you what? Minus 5 meter per second. So therefore, our v, velocity now, is going to be square root of velocity along x square, velocity along y square. This is going to give us 65.3 square plus minus 5 square. If you add everything and take square root, so at the end of the day, your speed will be 65.5 meter per second. So that is how we calculate what? That is how we able to what? Calculate the value of what? The position. The position is this. Then the x and y. The velocity is just vx and vy. Then you combine the two, you now have velocity at any time t. So this is when the angle is horizontal. That is theta is 0 and is going down. So these are the formulas. Then we have the d part. What is the d part? The d part says, so the d part say we have to find what? So please, let's wait. I think there is a... So the b part, but to find what? Now we have to find d. Our d now is to find the range. What is the range? U cos theta times what? Capital T. That's all. That is how to find the range. Then what is our u? Is 65.3 from the question. Cos, the angle is 0 because horizontally. Our time of flight, what is the time of flight? Time taken to reach the ground is 1.64. That is question A. A, we have got our capital T, which is that. So if you substitute all the values now, you are going to have 107.1 meters. So this is the range of the projectile, which is coming from this. Then the last part of the question is now what? We have to find the speed with which the body strikes the ground. So we say on the ground, capital T is TH, right? Then now, it's just like what we did before. We just get we are going to look for the velocity, question mark, but we first get velocity along x, which is u cos theta. Our u is 65.3. Theta is 0 degree. This gives me 65.3 because cos 0 is 1 meter per second. Then velocity along y is going to be minus, right? U sine theta minus gt, because this is going down, because sine is already negative in the fourth quadrant. The value of u is 65.3. Sine of 0 degree minus g is 10. The time, I'm sorry, this is the time of flight, because we are going to calculate the velocity with which the body strikes the ground. So we use capital T, and the capital T we have obtained it from question 2A, which is 1.64. Sine 0 is 0, so if you multiply there, you are going to get minus 16.4 meter per second. So therefore, the velocity with which the body strikes the ground, just like before, is Vx square plus Vy square. You have square root of the Vx, which is 65.3 square, Vy, which is minus 16.4. You square it, then you add it. Whatever you add, then your answer is going to be 67.3 meter per second. So this is how we do it. So question, do you have question? So is there anybody have question? Hello? Hello, is anybody have question? Okay, so if you have a question, you can raise up your hand. That is how we do for that one. Then the next example, which is the third one. So it looks like the other one, but now you see the angle is down. The question says, a stone is thrown downwards at an angle of this. So you look for the word. This is downwards. So you see, you look for downwards. So you see, look for downwards. At what angle? 30 degree. Then with the velocity of this from the top of a tower, this eye. You know this is what? Downward motion at an angle. So the height is given. So this is how you're able to figure out any question. It is upward or down, it is downward. Is it there's an angle? Yes. The height is given. So you now know we are now in that place where we're going to apply. Just like what we have done. So all what we have done is just the same thing with what we have done. It's just for you to change the value of theta to be what? 30 degree. It's all the same method that we are going to apply there in order to solve this problem. So for us to solve this problem, it is going to be very so it's going to be very simple here. So we go there and now get the solution. So now let's start with the solution now. Solution, let's first write our A. Question A. We are going to find the time taken to reach the ground. Before that, we know our theta is 30 degree. Our y naught is 0, x naught is 0, g is 10 meter per second square, u is what? Our speed is 3.4 meter per second, and then we are given the value of height, which is 29.1 meters, and is downward at an angle. Now we want to calculate the what? Time of flight. So just like a formula, h equals to minus u sine theta capital T, then minus half gt square. Okay. So now what happened now is to also substitute the values of this is minus our h is what? 29.1 minus u, our u is 3.5, sine of 30 degree. Whatever you have, you multiply with time of flight, which we are coming to find, minus half 0.5, g is 10, then t square. Then you are going to simplify the whole of this. When you do that, you are going to have minus 29.1 is equals to minus 1.7t minus 5t square. Multiply by this, we have this. Then now rearrange everything to that side. You have 5t square plus what? 1.7t minus 29.1 is equals to 0. So here you can see this is what? Is a quadratic equation. So therefore t is going to be minus b, which is 1.7, plus or minus the root of 1.7 square minus 4. A is 5. C is what? Minus 29.1. All divided by 2a. What is the a? Our a is, what we have, our a is 5. Now you are going to have two values here. When you try, you substitute, you are going to have minus 1.7 plus or minus 24.18 over 10. So therefore, t, if we use minus, the answer will be minus. So time cannot be minus, so we use the plus. So we are going to have minus 1.7 plus 24.18 divided by 10. And that answer will arrive at 2.25 seconds. So this is the time taken to reach a ground. Just like what we do. Just apply quadratic formula, then you are good to go. Okay, so the B part, just like what we did the other time. For the B part, we have to find the position at 1 second. We want to find x, then we want to find y. To find x, we know is u cos theta. U is 3.4 cos of 30 degree. So if you multiply all of these values, you end up going to have 2.94 meter. We find the value of y, which is minus, there is t, small t, and that t is 1. When you multiply, you have the same value. So you're going to have minus u sine theta times t minus half gt square. U is 3.4 sine 30, which is half, times t, which is 1, 0.5 times 10 times 1 square. If you simplify all this, your value of x is going to be minus 6.7 meter. The minus is mean we are in downward motion. So this is the value of the y, this is the value of the x. So this is the position of the object at any time 1 second. The c part is also similar, but this time around, we have to find what? The velocity at any time. That is, at this time, 1 second. We first get Vx. Vx is u cos theta. U is 3.4. Theta is 30 degrees. If you multiply that one, you're going to have 2.94 meter per second. We get the velocity along y. Velocity along y is going to be minus u sine theta minus gt. Minus u is 3.4 sine of 30 degrees. G is 10. T is 1. If you substitute that values, you are going to get minus 11.7 meter per second. So therefore, velocity at 1 second is going to be Vx square, Vy square. Vx is 2.94 square. Vy is minus 11.7 square. Multiply and square it, and then you add and take the square root. You are going to have 12.1 meter per second. So that is how to find the value of the velocity at any time. So this is how to find the velocity at any time. So you see, we're not able to get the velocity at any time here. We have. Then the next question, we have to find d. Let's see, how do we find the d part? So the d part says we have to find what the range. R is u cos theta times t. Our u is 3.4 cos of 30 degree. Our time of flight here is 2.25. Multiply, you are going to have 6.63 meter. So you see, so that is how we able to find the range, just like what we did that time. Then lastly, we want to find on the ground, what is the value of v? Okay, so now follow the same way. Vx is going to be u cos theta. I think we have to do this one, which is 3.4 cos of 30 degree. If you do that, you are going to get 2.94 meter per second. Then velocity along y is going to be minus u sine theta minus g capital T. That is time of flight. Minus u is 3.4. Theta is 30 degree. G is 10. And time of flight is actually 2.25. Multiply and then you add. You are going to get minus 24.2 meter per second. So therefore V is going to be square root of Vx square plus Vy square. Our Vx is 2.94 square Vy is minus 2.42 all square. So you add, you square this, then you add. At the end of the day, you are going to get 24.4 meter per second. So that is how we able to find the value of what? The value of what? The velocity with which the body strikes the ground, which we have already seen in the question. So this is how to go about them. So the questions are actually straightforward. Downward at an angle, you are given the velocity, then you are given the height. That's how to go about this. Then the other example we did before was this. The other example, it was what? Horizontally. Right? So the body was thrown horizontally from the height, and the speed is given. So we go ahead and also find that kind of problem. So you can see that is how we able to solve the downward motion, downward projectile motion, which is this one that we have seen. Actually, when the body goes down at an angle, the angle can be 0, can be between 0 to 90. When it's 0, we have seen example 2. When it's not 0, we have seen example 3. We're able to find all this value, to find the time of flight, the range, the speed, the position x and y at any time, and also the velocity at any time v. So this is how we able to go about them in solving this problem.